us will be solving this problem by matrix stiffness method using system approach. Now let me take this problem. This problem has three members, AB, AC, and AD, right? These three members are embedded into a rigid bond, which is BCD. That means B, C, and CD are not the members. So you have AB, AC, and AD are the members. Now this AB, AC, AD members have been loaded by 2-point loads 20 kilonewton and 20 kilonewton. Clear? Now you have for this problem it is mentioned that AE is constant for all the members. So they have not given area of cross section for each member. Area and Young's modulus is constant they have taken. So that means the constant in constant AE by L, what you need to have is in constant AE by L, AE is constant. So in this AE is constant. So that means in the table what you have to take is you have to take 1 upon L or L. Clear? Now let us take the ds value first step. So the dk value. So the degree of freedom here is if I take joint B, this is embedded into the rigid B, C, D are embedded. So that means joint B, C, D displacements are 0. So that means neither the displacement is along x direction nor it is along the y direction. Clear? But joint A, if I take it, it is free joint which has not been supported. That means this joint will displace along x direction, delta AX, and it will displace along y direction, delta AY. Clear? So dk is 2 here. So the free displacements are 2 here. What are those? It is delta AX and delta AY. So the degree of freedom here is 2. So for these two, what I have taken is I have assigned the coordinates as coordinate number 1 and coordinate number 2. So coordinate number 1 corresponds to delta AX and coordinate number 2 corresponds to delta AY. Clear? Now with this degrees of freedom, now I'll just calculate the stiffness matrix. Stiffness matrix. To develop this stiffness matrix, so I will just tabulate the results. So the results are you require member, you have three members here, you require theta. For this theta you require in AE by L constant. So AE is constant, so L is variable here for all the members. So I will take L here, right? And next is cos theta, sin theta. Next it will be 1 by L cos square theta one by L cos square theta 1 by L sin square theta and 1 by L cos theta sin theta. If suppose A by L is not constant, then you have to take A and E. A by L as you have to calculate A by L for all the members, and instead of L you have to take A by L there. So then you require A by L cos square theta and A by L sin square theta, A by L cos theta and sin theta. Clear? The first you have three members. First member they have mentioned it as they have numbered it 1, 2, 3. So 3 numbers. So first member is AB. So AB member, AB, AC, and AD. There are 3 members, right? So for AB member, the theta angle. So this angle is theta. This is theta. So if I take, if this is 3 meter, this is 3 meter, means this angle will be 45 degrees. Theta is 45 degrees, and this total angle for AB will be 180. This is also 45 degrees. This is 45 degrees, This is also 45 degrees, right? So it will be 180 up till here. It is 180 plus 45. So AB member will be 225 degrees. AC member is a straight member, so it will be 180 degrees. 180 degree, and AD will be 180. So this is the angle. This is the angle, right? So it is 180 plus 180 minus 45. So that 180 minus 45 will be 135. Right? Length for each members are AB is, you have to calculate those length of the member. Clear? By Pythagoras theorem you can calculate. So this AB length will be 4.242. AC will be 3 meters, and AD will be 4.24. Right? Now calculate cos theta sin theta. So cos theta sin theta will be minus 0.707, minus 0.707, and for AC it will be minus 1. Sin theta will be again minus 0.707. For 45 degrees cos theta sin theta are same, minus 0.707, and sine of 1 it is 0, right? So after getting this cos theta sin theta, so this I have taken it as L, right? So now I want 1 by L cos square theta. So cos theta, you have square of that divided by this L, right? You will get 1 by L cos square theta. So that 1 by L cos square theta, you will get it as 0.1178 for member AB, and for member AC you will get it as 0.333, and for AD you'll get it as 0.1178. Similarly, you have sine theta, square of that divided by L. So 1 by L sine square theta. So that will be 0.1178, 0.1178. Similarly, 1 by L cos theta sin theta. You have cos theta sin theta, multiply this cos theta and sin theta, that divided by L for each member. You will get it as 0.1178 for AB member. For AC member it will be 0, and for AD member it will be minus 0.1178. Now after this, get the summation. The summation will be 0.5686. This is 0.2356, and this will be 0. So that means your K11 value will be AE is constant. So AE is constant. You have summation of 1 by L cos square, 1 by L cos square theta, 1 by L cos square theta.
Sir,
See, K11 will be AE summation of 1 by L cos square theta, which will be 0.5686 AE. K22 will be AE into summation of 1 by L sin square theta, which is 0.2356 AE. You'll get it. Similarly, K12, K21, it is AE into 1 by L cos theta sin theta. AE is constant, right? So this will be 0, right? So the finally your K matrix will be AE into bracket K11, that is 0.5686, K21 0, K12 0, and K22 0.2356. So this will be your K matrix, right? After getting this K matrix, next step is third step, the locking force matrix P dash. Now again this problem is unyielding, no any of the joint is not sinking here, so therefore your P dash matrix will be 0. Your P dash matrix will be 0, right? External force matrix, again next step, external force matrix. This external force matrix is the P matrix. That means the force along external force along coordinate number 1 and external force along coordinate number 2. So the external force along coordinate number 1, see, I have a coordinate 1 here. I have a coordinate 1 here. So this coordinate 1, you have along this coordinate 1, you have 20 kilonewton load. It is along the same direction. So it is plus 20. Along coordinate number 2, I have taken coordinate number 2 as upward. You can assume any direction here, right? But I have assumed it as upward. But your 20 kilonewton load along y direction is downward. So along y, along coordinate number 2, the force is 20 kilonewton, but it is opposite to the direction, so it will be minus. So along 1 it is plus 20, along 2 it will be minus 20. Clear? So this is the external force matrix. Plus 20, minus 20, right? Now with this, you can calculate the unknown displacement now. Unknown displacement matrix. So this unknown displacement matrix delta, this unknown displacement matrix delta is K inverse into P minus P dash. As P dash matrix is 0, right? So this unknown matrix K delta will be, it will be K inverse into P, right? So K inverse is 1 by A, it is AE into bracket 0.2356 0 0 and 0.5686. Sorry, it is 0.5686 0 0 and 0.2356. That inverse of this into P matrix, plus 20 minus 20, right? So this inverse will be 1 by AE, it will be, right? It will be 1 by AE into bracket, inverse of the matrix is, change the principal diagonal element. So this will be 0.2356. Change the sign of the other two elements. It is 0 only. So this is 0.568. This is the cofactor, right? That divided by the determinant. Determinant is 0.5686 into 0.235 minus 0 square, that into the P matrix 20 minus 20, right? Now this you can calculate, so you will get the answer as 35.16 and 84.86. You'll get the answer as this, that into 1 upon AE. So this is delta 1 and this is delta 2, right? So what is delta 1? So delta 1 corresponds to delta 1 corresponds to delta 1 corresponds to see delta 1 corresponds to the delta AX and delta 2 corresponds to delta AY, right? So delta 1 corresponds to delta AX which is 35.16 divided by AE, and delta 2 corresponds to delta AY which is 84.86 divided by AE, right? So these are the unknown displacements. After getting these unknown displacements, what you can do is you can directly calculate the member forces. Next step, member forces. So the member SF, you have FAB, AC, AD. So FAB will be, what is the equation? FAB, so it is minus AE by L into bracket delta, in the order it is, in the order of A and B, delta AX minus delta BX into cos of theta AB, right, plus delta, again in the same order, delta AY minus delta BY into sine of theta AB. Right? It is minus AE by L. So AE is constant, so you can take it as you can keep it as it is, AE. So minus AE. The length of the member AB is 4.242 into bracket delta AX. You have delta AX and delta AY. You have similarly remaining delta, that is remaining displacement, that is delta BX equal to delta BY equal to delta CX equal to delta CY. These are all 0, right? There are no displacement for joint B and joint C, only you have at joint A, so which is 2 degrees, right? Now calculate this. Delta AX is minus it is 35.16, right? 35.16 divided by AE, 35.16 divided by AE. So this AE and this AE will get cancelled. Clear? 35.16 divided by AE into the cos of theta AB. The theta AB already there, it is there in the table. So cos of theta AB is 0.707 minus 0.707, right? Plus delta AY is 84.86 divided by AE, 84.86 divided by AE into the sine of theta AB. So what is that sine of theta AB? Sine of theta AB is minus 0.707 again, minus 0.707, right? And if you calculate this, you will get it as FAB is equal to 20 kilonewton, which is you are getting positive. So which is for the other two members. Other two members are FAB is over FAC. FAC is minus A by L minus AE by L. L for member AC is, I'll just write, if you want the formula, I'll just write it, minus AE by L into bracket delta, in the order delta AX minus delta CX into cos of theta AC, right? Plus delta AY minus delta CY into sine of theta AC, right? If you substitute, it will be minus AE by L minus AE constant divided by length of member AC. AC length is 3 meters into bracket delta AX. Delta AX is 35.16 divided by AE into sine cos of theta x AC. It is minus 1, and delta CY sine of theta AC is 0. Sine of theta AC is 0 anyhow, so this term will be 0. So you will get it as FAC as 11.72, and you will get it positive, and this will be tension, right? Similarly, FAD, it will be minus AE by L minus AE, and length of member AB is 4.24 into bracket delta AX is 35.16 divided by AE minus delta BX, which is 0, into cos of theta AB, which is minus 0.70. Sorry, it is, I think I'm calculating for AD, right, into 0.707 plus delta AY, which is 84.86 divided by AE into minus theta delta BY, which is 0, into sine of theta AD, which is 0.707 again, right? Now this will be, FAD will be equals to minus 8.28. You are getting negative, right? So this is compression. Clear? So this is how you can calculate the member forces by matrix stiffness method using system approach. You can draw the you can show the member forces in the form of a figure also. You can show it like this, right? This is A, this is B, this is C, and this is D. So member AB is 20 kilonewton tension. AB is 20 kilonewton tension, 20 kilonewton away from the joint, right? Tension. AC is again 11.72 tension away from the joint, 11.72 kilonewton, and AD is compression, which is towards the joint, right? So it is 8.28 kilonewton. So these are the member forces. So this is how you can calculate the member forces by matrix stiffness method using system approach. Thank you.